In this video, we're going to talk about integrating powers of secants and tangents. So we're going to assume our integral looks something like this. The integral of tan to the m power times secant to the n power. And we're going to assume that m and n are both positive, right? They're going to be at least non-negative integers, but for this we're going to assume they're positive, right? If one of these is 0, m or n is 0, right, then you're back in to the case where you're integrating just tangent or just secant. So we're going to assume they're positive, so there's at least one of each in there. And then when you do that, these integrals are going to split into 3 cases. And this is really similar to the sines and cosines where we had 2 cases, right? In this one, we're going to have 3 cases to deal with. So case 1 is when n is even, so that's the power of secant is even. Case 2 is when the power of tangent is odd. Okay. And then case 3 is where m is even and n is odd. So that's sort of the opposite of this case here. Okay, so I'm going to go through case 1 and then I'll put case 2 and case 3 in just videos of their own. So, all right. So let's take a look at case 1. Case 1 is where n is even. That's the power of secant, right, is even. It's 4 here, right? And so how would you go about doing that? Well, if the power of secant is even, right, what you want to do is pull off a factor of secant squared. Just like we did for cosines and sines, this secant squared is going to become my du in a substitution. Okay. All right, so that drops this power by 2, right? So I have a secant squared over here. What do I do with this one? Well, what you're going to do, right, I pulled off a secant squared. You're going to change this to the other trig function, which is tan in this case, using the Pythagorean identity. So this secant squared right here became this tan squared plus 1. Okay? All right, and so now I'm going to distribute that tan to the 8th power through the parentheses. And so now all I've got in here are tangents, right? And look, I've got the derivative of tangent, secant squared, just waiting outside here to become the du. So now you're ready to do the substitution, right? You're going to pick u equal tan x, and then your du is going to be secant squared x dx. Wow, that's crazy how that secant squared x was just waiting out there to the side for me, right? And that's by design. I knew it was going to come down to that, so I pulled that off, and so that would be waiting just for this step right here. All right, next up, go ahead and make your substitution. So tan to the 10th is going to be u to the 10th, plus tan to the 8th is going to be u to the 8th, and then secant squared dx, all of that's just going to become du. So it boils down to this really simple integral, right, of a polynomial. Okay, so we just apply the power rule to this guy, add the 1 to the power, divide by the new power, add 1 to the power, divide by the new power, right? And then put a plus c. And then the last step is to back substitute. Remember, u was tan x, right? So the final answer on this one is 1/11th tan to the 11th x plus 1/9 tan to the 9th x plus some constant c. Okay. All right, so anytime, right, you have that situation, right, where n is even, what you're going to do is split off a factor of secant squared, and then you're going to use the Pythagorean identity for secant and tangent to convert all the other secants to tangent. Not the one you pulled off, but every other one will need to get switched over to powers of tangents, and then it's just a straight up integration by substitution with u equaling tan x, and it should fall right out. So, all right, that's it for case 1. In the next video, we'll talk about case 2.